This agent is missing one key piece. What actually makes an AI agent different from a normal Python program? In this tutorial, we will build the core Python workflow that an AI agent can use, receiving a goal, calling a controlled tool, processing the result, and returning a structured response. Before we begin, there is one important distinction. The project in this video is not yet a complete model-driven AI agent. It is a simplified agent-style workflow written with normal Python logic. This will help us understand the architecture first. In the next tutorial, we will connect a real language model so it can choose tools and generate responses dynamically. Welcome to TD SASH, where we build practical projects using artificial intelligence, Python, and software development. Let us begin. A basic chatbot receives a message and produces a direct response. An AI agent goes further. It can receive a goal, choose an action, observe the result, and decide whether another step is needed. Asked to research a topic, a chatbot answers from existing knowledge. An agent chooses a tool, gathers information, and prepares a summary. However, agents are not always correct. They can choose the wrong tool, provide invalid arguments, or misunderstand the goal. That is why production agents need validation, limits, and human approval for sensitive actions. A useful way to understand an AI agent is through 5 common building blocks. The first is the language model. The model interprets the request and decides what action may be useful. The second is the goal or instructions. These define what the agent should achieve and what rules it must follow. The third is memory, which is optional. Memory can store conversation history, user preferences, or previous task results. The fourth is tools. Tools allow the agent to search information, query a database, perform calculations, or interact with another system. The fifth is the execution loop. The agent performs an action, observes the result, and either continues, asks for clarification, stops after an error, or ends when a defined step limit is reached. Our project will contain 2 Python functions. The first function will look up information from a small local knowledge source. The second function will organize the result into a structured response. Python will control every step in this version. The program will not dynamically select tools or generate new information. That behavior will be added after we connect a language model. Before writing code, let us design instructions a future model-driven version could use. Understand the topic, choose an approved tool, and never invent information. Displaying instructions alone does not change an ordinary Python function. They only take effect once we pass them to a language model. Now, let us create our first controlled tool. Instead of calling it search_knowledge, we will call it lookup_knowledge because it performs a local dictionary lookup rather than a real internet search. The function first removes extra spaces and converts the input to lowercase, so inputs like uppercase text or accidental spaces can still match our stored topics. If the topic is unavailable, the function returns a clear fallback message. In a real application, this tool could later be replaced with a document database, company API, or approved web search service. Think of lookup knowledge as a librarian who finds the right book, and research workflow as the writer who takes that book and produces a clear summary. One finds the facts, the other shapes them into a structured answer. Next, we will create the workflow that calls our lookup tool and packages the result. This function receives the topic and calls the predetermined lookup tool. It then inserts the returned information into a predefined summary template. Finally, it returns a Python dictionary containing the topic, research data, summary, and next step. This is important. The program is not analyzing the information intelligently. It is following the exact workflow we defined in the code. Both pieces are ready. Let us run the workflow end to end and see exactly what it produces. Let us test the workflow using the topic AI agents. An assert statement checks the topic came back unchanged. Then we print the summary and next step. The workflow found a matching entry and returned the result using our predefined structure. What do you think will happen if we request a topic that does not exist in our knowledge source? Let us test it. The fallback works correctly. In a production application, we could return a structured error, ask the user for another topic, or allow a real agent to choose a different approved tool. To make this a genuine model-driven agent, we connect a language model with the goal, the instructions, and the available tools. The model chooses a tool and arguments. The application, not the model alone, validates them, executes the tool, enforces a step limit, and stops safely on error. Before deploying an agent, add safety controls. Never allow unrestricted command execution. Validate tool names and arguments. Store credentials securely, and require human approval before sending emails, deleting files, or changing production systems. Log every tool call, its result, and any errors. Let us review what we built: a controlled lookup tool, a structured workflow, a real test, and a safe fallback. We also learned how a genuine agent differs. It uses a language model to choose tools and decide the next step on its own. Next, we connect this to a real language model. Subscribe to TD Sash. See you next time.